What is the solution then? A straight line. So y equal to beta naught plus beta 1 x function, which produces a straight line. That did not work. Are there any other non-linear lines that you can tell us where we will try to fit and see whether they will work or not? Let us check some of the functions that are non-straight line. Okay, there are polynomial function, Gaussian, quadratic, sine, Lobel exponential, exponential. There are several functions. Maybe all of them are not straight line, but that doesn't mean you can take any function. You can simply take the sine function and apply it to our data. That also may not work. Out of all these functions, which function suits best for our scenario, for our particular data? Our particular data is in a particular style. Either we have all zeros here, maybe people who are not buying, either we have all ones. There are still some values here, but mostly the concentration of the data is like this. If this is the case, what type of model we should build? Sine will be like this. Forever it will go on like this, infinity to infinity. Shall I build this one? So sine only I have shown you a part of the data. Do you think sine will work? No. Which one? Which function? Is it polynomial? No. Gaussian? Hell no. Quadratic? No. Exponential? No. Double exponential? Yeah, almost one side it is covering. But what about this side? Nope. No way. This also doesn't work. Logistic is the one that will best suit our type of data. It may not go through all the data points, but it looks like it has the maximum coverage. I'm not saying logistic will be 100% accurate model. No, I am not. But it has the maximum chance to go through and represent our data. So instead of building a linear regression line, which is a straight line, instead of building a linear regression line, what line I'm building? A kind of S curve, an S curve looking like function. This is known as logistic function. Obviously, there must be an equation for this, but it will be somewhat very complex. It will not be as simple as this equation. Yes or no? The beautiful property of logistic regression is its minimum value is 0, maximum value is 1. It will never go beyond 1. It will never go below 0. So there is an equation for this S looking curve. Okay, the equation of logistic regression line. Obviously, there is a way you represent a straight line. There is a way you represent this curve as well. This is given as y equal to e power beta naught plus beta 1 x1 divided by 1 plus e power beta naught plus beta 1 x1. This is your logistic regression line equation. The way this represents a straight line, definitely this represents an S curve. This is known as logistic regression line. So instead of building a linear regression line for this data, what line we have to build? We have to build logistic regression line. Why are you building logistic regression line? Because that seems to be the best possible output that we can get when we build this regression line. Now in linear regression line, when you are building it, what are you finding? When do I say I have the linear regression line in front of me? When I have the values of beta naught and beta 1, then I would say, hey, I'm done with model building. I have the beta naught value, beta 1 value. Then what are you finding here in logistic regression? Tell me. What are you finding here in logistic regression line? What are you trying to find in logistic regression line? When you are building logistic, here you are trying to find beta naught and beta 1. What are you trying to find here? Even here you find beta naught and beta 1 only. But the way you write the equation, that forms this S curve. The way we are finding the beta coefficient, while finding itself, we start with this equation. Accordingly, these values will be fine-tuned. Accordingly, this error will be minimized. We will get the best suitable logistic regression curve that will go through maximum points in the data. So this is your logistic regression model. What is the equation? Once again, y equal to e power beta naught plus beta 1 x divided by 1 plus e power beta naught plus beta 1 x. This will make sure that your data is going through maximum points. See, obviously, this is not 100% accurate model. Do you agree with that point? There are some points it will be wrongly predicting. There are some points it will definitely wrongly predict. But who is aiming for 100% accurate model? We also know even in linear regression, if our model is usually 80% accurate, we are fine with it. Maybe there are some points it will do misclassification even now. But we want such line that will go through maximum points in the data. So for our particular problem here, the bottom line is, instead of building a linear regression line on product sales data, what you need to build is logistic regression line. What is the difference? Instead of saying LR, linear regression, you would say, hey, build logistic regression. That's it. That's the only difference. So we will go back to the code. Earlier we said LR equal to linear regression. Now we will say model equal to logistic regression. Here itself I am saying, do not build a straight line. Do build e power x by 1 plus e power x. This kind of curve you have to build. Logistic dot fit x variable, y variable. You will get the coefficient which is beta 1. You will get the intercept which is beta naught. Then get the predicted values. Earlier, if you remember the predicted values, we got a negative value using regression. We got some +2 using regression, which were wrong predictions. Let us see what will be the logistic regression prediction. Logistic regression prediction. Quickly go back to your code file. Get me the predicted values using logistic regression line. Go ahead, all of you. Tell me the logistic regression line predictions. So one by one, let us build the logistic regression line. Let us get the intercept, which is beta naught, coefficient beta 1. When the age is 4, the predicted value happens to be 0. When age is 105, the predicted value happens to be 1. So 0 is the predicted value. 1 is the predicted value by logistic regression line. These are the predicted values.